Thank you. Hi everyone. Thanks for coming to my talk. Very excited to be here. Little word of advice: never write sort of an abstract as a tongue-in-cheek joke and then submit it to a conference, because you risk that they actually accept it and then you'll have to do the talk. My initial reaction to this Agile meets architecture is like, well, that's funny because they're both dead. In the sense that architecture was murdered by Agile sometimes in 2001 in the assassination plot to overturn Waterfall. And since then, 20 years have passed, and sort of Agile has some health problems too. Well, so that's what we're going to talk about. A few words about me. My name is Einar Høst. I'm a Norwegian software developer. I have been making software for money for roughly 20 plus years, so roughly as long in the industry as the Agile Manifesto. I did my master's degree in computer science in 2002. Then I worked as a programmer for 3 years. Then I did my PhD, and after that I was a consultant for 7 years. I worked 6 years in TV streaming. And yes, since last year, I work for the Norwegian Labour and Welfare Administration, which is basically like the executive branch of the Norwegian welfare state. It's a fairly large organization. We administer roughly a third of the national budget in Norway, and we use that to pay services such as unemployment benefits, sickness benefits, childcare, pensions, and so on and so forth, basically from the moment that you're born as a Norwegian citizen and until at some later point you're sort of unborn. NAV has services in place to help you if you should need it. Yes, Agile and Architecture. So if I get it right, sort of the basic premise of this conference is that the world of Agile and the world of architecture are sort of separate camps, and there's a certain tension there, right? And there's somehow at odds, and maybe architects and Agile practitioners don't always see eye to eye. But if we meet up and talk together, maybe we'll find some common ground. And discover that we can sort of get along. Now, often in discussions like this, we talk about striking a balance, right? And this is an idea that comes up a lot. You can arrest me if I'm mistaken, but at least that's my impression. Now, again, this plays into this view that Agile and architecture are somehow opposites. And so we get into discussions of, well, how much architecture should we have, right? Which sounds a little bit weird to me, because you mean like in kilograms? Or maybe in volume? What's the unit of measure for architecture? And I guess the underlying idea here is that if you have too much architecture, that's somehow going to stifle your agility. And similarly, how much agility should we sort of aim for? Which I guess sort of translates into how much autonomy should teams be afforded. And the idea here is something like, okay, if it's too much autonomy, somehow the architecture is going to crumble and everything is going to go very badly. And then the answer tends to sort of end up, well, it's going to be just enough of each, right? We don't want too much, we don't want too little. But that's sort of useless. It's sort of like a tautology. Obviously, we want just enough, right? But it doesn't really tell me anything. It's not a heuristic that I can use. But I think our brains are sort of wired to look for these balances. Trade-offs are much easier. We could sort of just reject the extremes, and then we'll be placed somewhere sort of meaningful in the middle. But that sort of requires that it's actually opposites on a scale, and I'm not sure that's the case. So I don't want to do one of those balance talks, and I don't want to talk about the pendulum sort of swinging from sort of heavy architecture to too much agility, and then now we're sort of approaching somewhere in the middle. I don't want to do that talk. I want to talk about something else. I want to start with why. Why are we talking about these things in the first place? For instance, why are we talking about architecture, right? Why do we have such a thing? What are we trying to accomplish? What is the problems that we're trying to solve? Same thing for Agile. We have this notion of agility. What are we trying to accomplish with it? In fact, why do anything, right? We do things because we sort of perceive that they bring some sort of value. And if you think that something else is going to bring more value, you do that instead, right? We should never do something. Well, it's kind of obvious that we have these things sort of big topics at software conferences, agility or agile and architecture, they are realities, but we should never do something just because we're already doing it and have been doing them for a long time. We do it because, presumably, it brings some sort of value. So we need to ask questions like these, like if architecture is the answer, what is the problem? And similarly, if agile is the answer, what is the problem? And an interesting question, at least to me, is it the same problem? Are we trying to solve the same problem? And it's common to talk about this notion of the software crisis. And then we have to go back to 1968. I'm sure you're familiar with this story, and the NATO conference about software engineering, where they first sort of articulated this problem of the software crisis. And the problem was that software projects are sort of running over budget, over time. The software was very inefficient, it was full of bugs, sometimes it wasn't delivered at all, it didn't meet the requirements, and so on and so forth. And there's this quote by Edgar Dijkstra. I'm just going to read it out. It says that the major cause of the software crisis is that machines have become several orders of magnitude more powerful. To put it quite bluntly, as long as there were no machines, programming was no problem at all. When we had a few weak computers, programming became a mild problem, and now that we have gigantic computers, programming has become an equally gigantic problem. This is 1972, and it's fair to say that computers have become more powerful since then, and also much more ubiquitous. So software is everywhere, right? So I think we've had this crisis for 50 years. It's fair to say that it's going to remain with us. In a field that sort of constantly changes, this is one of the constants. In fact, ambitions are going to continue to rise. Software is already everywhere. There's just going to be more of it. It's going to be more sophisticated, and we're going to want to accomplish more for less. So how do we tackle the crisis then? Well, in the 70s, you had people like Edgar Dijkstra and David Parnas talking about like the structure of the program and looking into modular design, sort of how do we partition and put together our software. And there were sort of high hopes for the notion of components, right? And ideally, components, if we had good components that could be reused, maybe we didn't have to write everything from scratch all the time. And then you can sort of bypass the entire ordeal of writing software, right? You don't need to sort of get rid of all the bugs and so on and so forth, because you already did that. You just reuse things that are already been made. And eventually, this sort of turned, over time, this sort of turned into this idea of software architecture. And in 1992, Perry and Wolf had a paper where they predicted that the 90s would be the decade of software architecture. And I think they were definitely right about that, maybe even more right than they intended to be. We saw sort of in the 90s then the rise of the architect. Now there's this, well, what is architecture? There's this joke that architecture is what architects do, and what does an architect do? Well, it tends to the architecture, right? Here's the definition. There are like a gazillion definitions of architecture. I'm not sure, it doesn't necessarily speak ill of architecture that there are so many definitions, but it doesn't necessarily speak good of it either. This says, the architecture of a software system is its organization or structure of significant components interacting through interfaces, those components in turn being composed of successively smaller components and interfaces. This is from the Rational Unified Process, so sort of mid-90s, I guess. So the 90s gave us a unified process, it gave us a unified modeling language. We got a 4+1 view model for sort of illustrate different aspects of the software system and so on and so forth. Of course, there was the patterns movement also in the 90s, which took inspiration from a real sort of like buildings architect, Christopher Alexander. Some of you may have heard about and maybe even read some of his books. And I think there was much hope in sort of this idea of capturing known architectural patterns, and not just components, but use those patterns to compose better architectures, and then, as a result of that, better systems. The most prevalent architectural pattern was identified in 1997, the big ball of mud. Unfortunately, everyone has heard of the big ball of mud, but very few people that I've met have actually read the description of the pattern. And that is a shame, but I guess it's sort of unavoidable in a pop culture with software development is. Only the sound bite sort of survives, and the analysis behind it sort of dies. But since I have you here in this room, I'm going to place a curse on you. You will not be able to utter the words big ball of mud until you've actually read the pattern. The words will sort of turn to lead on your tongue. Let's see if that works. But OK, so since the sort of the earlier definitions of architecture, it seems to me we had some scope creep, and that happened quite quickly. Sort of went from talking about how do we put together components to more sort of talking about things, properties of the system, quality attributes, stuff like security, scalability, resilience, and so on and so forth, and testability also. So it sort of got more abstract, and we had definitions like this. Right? Architecture represents the significant design decisions that shape the form and function of a system, where significant is measured by the cost of change. And this is by Grady Booch. I'm not sure the sort of exact time or year. My impression is that Grady Booch still promotes something along these lines. Right? But OK, so that's software architecture. How did it go in terms of the sort of solving the software crisis? Well, from the abstract, also from history, we know that it didn't go too well. Right? Architecture was killed in its sleep by the assassin known as Agile, as part of the plot to overthrow Waterfall. But an interesting question is why? Why did this happen, right? Because, and when we talk about that, we're going to have to get, I think, a little bit uncomfortable. But at the same time, or perhaps precisely because it's uncomfortable, it's important to talk about it. Right? It's important to be honest about these things. And if I were to sum it up, I'd say the problem was irrelevance and harm. I'm not going to say that there was no good architecture work done in the 90s. Obviously, there was, right? But at the same time, many people experienced architecture, and perhaps architects in particular, as useless in the best case, and actively harmful in the worst case. I met many developers who said that they've never experienced working with an architect. They worked with software architects, but they never experienced working with an architect that did more good than harm. And that's terrible, right? It's pretty harsh words, but it's extremely important, I think, to take those experiences seriously. Otherwise, if you just sort of start blaming the messengers and saying this can't be true, then we're not going to learn anything. But again, it's important to ask why. How could something like this happen? Because architecture sounds good, right? There are important concerns that we need to talk about. One thing we might ask is why did we sort of end up with an architect to deal with the architecture? And an early idea, I think, was the idea of the necessity of sort of conceptual integrity. Right? In the systems that we're trying to build, it's a good thing if it could be the brainchild of a single person, that person's unique single vision that sort of unifies everything. And this matches the sort of the idea of the master architect as the master builder, and then you can have sort of minions to carry out the menial task of implementation. That idea sort of points in an entirely different direction, which has to do with money. Right? Because skill costs money, and it's much cheaper to have one of these expensive architects, and then you have a sort of cheap code monkeys to do sort of all the nitty-gritty details. And they can help multiply the impact of your expensive person. And so, unfortunately, I think we often saw organizations implementing architecture through an architect as sort of this anti-pattern. You placed, in this case, 8 teams being served by a single architect, or maybe a board of important architects in the middle, and there are a bunch of problems with this arrangement. And this is obviously not the only possible arrangement, but I think in many cases this is what we got. So we had the architect as a bottleneck then, because sort of communication was asynchronous, so the team had some need, and sort of raised the concern to the board of architects, and then sort of had to wait for clarifications and decisions. And it's slow, and it's sort of detached from reality, because there's no way that the architect can sort of know the context of each team as well as the team knows it itself, right? It never has the full context in mind, and it can't have that in this arrangement, which in turn leads to poor decisions, loss of trust, and this sort of the whole thing erodes. There's also potential conflicts of interest. If you ask teams, what do you want from architecture, what are they looking for? They want something that's fit for purpose, something that helps them. They want something that's as simple as possible. They like something that is specific. It solves a particular concern they have in their particular context. It just needs to take local concerns into account, right? But it's vitally important also that it takes those into account. It doesn't have to solve all the problems in the world, but it's better to solve those that they have. And whatever you choose, it should be something that makes the system sort of understandable from within. An architect might have other goals, other priorities, in fact, other things that the organization wants the architect to achieve. Uniformity might be a goal. It might be better from the architect's perspective to have a general solution than a specific one. And you want the system to be sort of understandable from the outside. Now, it's important to note that this is not about people, really. This is about systemic properties of this arrangement. It's not that the architects were necessarily doing a bad job, but in many cases, they were working in a bad arrangement, which led to bad results. And then 2001, the Agile happened. I said it was an assassin, but it was perhaps more like a revolution, right? So 2001, February, we got this thing. Individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. This is the Agile Manifesto, which sort of changed everything, right? Unfortunately, as often happens, and perhaps quite predictably, nuance quickly gets lost, right? So it wasn't the intention of the Agile Manifesto to sort of completely ignore all of these other things, but that's sort of where we ended up, I think. This spells bad news for the architect, because if you look at it, processes and tools, documentation, laying out a plan and following it, maybe that sort of sounds to me that it falls into the domain of the architect, right? So that, a bit crudely, spells the death of the architect and the toppling of the ivory tower, if you like. So, where did we end up? Sort of when the smoke settled and sort of the revolution was over, out of the smoke emerged sort of Scrum and Jira. That's what we were left with, which is a little bit ironic, perhaps, because that sounds to me like a process and a tool, which doesn't match the first statement in the Agile Manifesto very well, which has individuals and interaction over processes and tools. But oh well, that's perhaps predictable turn of events, because at least processes and tools are very tangible. It's more like a fuzzy goal, this with the individuals and interactions. How do you sort of roll out something like that? And so we had the Scrum Pact. And this was a very interesting thing I learned only recently. It was a series of posts by Alistair Coburn, who said that Scrum struck a magnificent deal in hostile territory. Right? Management got sort of like 12 times a year, if you count like 1-month sprints, where they can change direction in any way they wanted. Whereas the teams, their part of the bargain was that they got a month of sort of quiet and no interruptions, and they didn't have to deal with changing in direction in that month during the sprint, right? And then they could sort of just focus on working. But this idea that Scrum was invented to function in hostile environments, that was sort of new to me. But it makes things make more sense in my head. Because it's sort of like this interesting contract between you have your sort of your hard-pushing executives from the business side, and you have these developers needing time to think. So it's this compromise, I guess. Over the last 20 years, Agile has seen some scope creep too. We started, this manifesto was the manifesto for Agile software development. So the focus was on software development. Since then, I think this has turned into more like a focus on agile product development, which is actually quite a big leap. And perhaps even agile organizations, right? Because we want our businesses to be agile and be able to do business in an agile way. Sort of pushing this frontier of the agile movement, we've had like an endless stream of self-help books from Silicon Valley. Basically, all the Silicon Valley unicorns, all the winners, have written up their sort of recipes to be followed, confirmation bias be damned, if you like. They're selling all of these books, various kinds of what you might call radical pixie dust that you could sort of sprinkle on top of your agile transformation in hope that will actually sort of go from agile software development to fulfilling the agile dream of doing proper agile product development in agile organization, pushing agile business. An interesting question that is, has it worked? I think we've certainly tried. Right? But it's hard to talk about these things because everything is always a success until it's abandoned. Right? And what I mean by that, if you ask a team today that's implementing OKRs if it's going well for them, they will be very enthusiastic. If you ask them in 3 years' time how it went with the OKRs, let's see how that goes. Maybe it's going to go very well, but we don't know that yet. And we've tried other things before, other kinds of pixie dust. So we'll see. It seems to me that very little actually sticks of these things that we try. And this, in turn, has made things get a little bit weird. And what I mean by that is the sort of the ideals that we have for teams and for organizations, they have evolved a great deal since over the last 20 years, since the manifesto was written. So we have ideals of bridging the gap between business and IT. We want customer obsession, just as customer obsessed as Amazon is. We want our teams to be. We want a seat at the table, and so on and so forth. Whereas the reality, it seems to me, is largely the same. What is that reality? That is the Scrum Pact. When I think of the Scrum Pact and how we do software development now after 20 years of Agile, I think of this. And this is sort of what the Scrum Pact set up is this idea of a productive terrarium for software development, where you shelter the team from the environment, because that's sort of somehow toxic, right, and disturbing. And then you try to sort of control and optimize the conditions inside this terrarium that you've created. And then you want to avoid too much and too little of everything, right? If it's too much, maybe people get demotivated. If it's too little, maybe they get lazy. And then inside, the developers are like these busy silkworms trying to produce software, right? And then you ask from the outside, are you feeling safe? Are you feeling productive? Are you thriving inside, right? And all the while, perhaps sort of having this mild pressure that could you please produce a little bit more this sprint, right? A little bit faster, a little bit more, and have you set your stretch goals? And are those stretch goals stretching you, I guess? The problem with this terrarium is in the protection. Okay, because it sort of limits the kind of feedback you can have, because the communication then needs to pass through walls. And basically what typically happens in organizations is they have a messenger. Right? The team has a messenger in the form of a team lead, or perhaps some magical being that can pass from inside the terrarium to the outside and bring messages, and hopefully bring messages back. But that's very indirect, and it's asynchronous, and it's slow, and it leads to sort of bad decisions and loss of trust, which sounds a little, in fact, a lot like what we were talking about with architecture before. So I'd like to mention a couple of uncomfortable truths, at least truths as the way I see them, about this as well. And the first one is that while sort of software developers have learned the ideals of Agile by heart, in many cases they prefer the safety of the productive terrarium. Life as a silkworm is quite comfortable. I guess silkworms feed on mulberry leaves. Instead of that, sort of software developers feed on Jira tickets. right? And if we stray from the sort of agile ideals, it's because of the management on the outside not allowing us to follow them. And if anything goes wrong, it's due to things happening outside our control. Of course, the second uncomfortable truth is this idea of command and control obviously never died, right? That's still out there. Sort of the toxic environment that we wanted protection from, that's still out there, right? So that didn't die. Which reminds me of this is one of my favorite quotes by Henrik Ibsen. It says, "Don't use that foreign word ideals. We have the excellent native word lies." So we're not being completely honest, I think, about what we're doing, and that makes things weird. Okay, so where does that leave us? Architecture is dead. Agile isn't agile. Now what? How do we tackle this crisis that we're in? I guess, again, we need to go back to see what the problem is. And in some fundamental way, I guess, the problem is the passing of time. So the biggest unsolved and unfortunately unsolvable problem in software development is the passing of time. Time brings change, and if with time would stand still, we might eventually catch up and reach a steady state, and everything would be good. But we have change, and we have to deal with it. What kinds of change? There are many kinds of change that can affect software. I think when we talk about change, at least originally, so when Kent Beck talked about change and embracing change in the sense of extreme programming, often we were talking about requirements. So the fact that requirements change, that's sort of a fact that we need to accept and sort of embed in our process. Our domain might change, our business might change. But of course, technology changes constantly as well, and in fact, much more rapidly than our business typically changes. So the domain changes are slow. They're sort of dramatic when they happen, but they're not that frequent. Technology changes are very frequent. In fact, I think it's useful to sort of think about the change surface for our systems. What sources of change are we exposed to? And today, this is important because today, most applications are like iceberg applications, right? There's a little bit of our code on top, and then there's sort of this deep, murky part underneath with all the dependencies, right? And it's kind of weird state of affairs, but where often we don't even know what that set of transient dependencies are, right? We're reusing all these libraries that reuse other libraries. But any change that affects any of those dependencies, whether we know about them or not, are changes that we might need to react to. Typically, in the sense that if there is a vulnerability in one of those dependencies, we might have to do something. Now, problem is that code is dead. This is sort of a fundamental problem with change. It means that code cannot respond to those changes by itself. Any change that affects the code need to be responded to by people. Only people can respond to changes. And in that sense, only the combination of code and people is alive. So in some very real sense, software systems are really cyborgs, right? And we know this instinctively. There was a discussion at Slack at work just a few days ago about some library that I think was used that could produce PDFs by converting from HTML or something like that. And apparently, the maintainer wasn't active anymore. And that sort of started some panic, because a lot of people were using this library, and what should we do? We need to find an alternative, right? As we know that the library is dead once the maintainer leaves. Sometimes we talk about labeling this socio-technical systems instead. It's the same thing, right? But it's important to note this because, again, whole new categories of change come that can affect the cyborg if we sort of count people among the software system. Funding is cut. That's sort of a dramatic change, right? It could be cut entirely, which means that everyone goes, or maybe just cut a little bit, so one developer has to go. Any team change is going to be relevant for the software system. It's going to bring about knowledge loss. Maybe an important contributor quit, or it's just going to change the team dynamics. That's also a dramatic change, potentially. So what we need to do, our task, I guess, is to build these sustainable cyborgs. Now, when we want to build sustainable cyborgs, it's important to realize that one other thing that's constant in software development is human vices, which is our sort of innate human traits like laziness, vanity, and so on and so forth, our tendency to choose simple solutions over things that actually work. Those are constant, and we have to take those into account. So solutions must be systemic. It's never going to be enough to sort of talk about discipline or professionalism or stuff like that. That's just fancy speak for trying harder, and we can't try any harder, right? We're just humans, right? So we're not going to be more successful than whoever preceded us, right? So some things we might try on the organizational level. Let's start there. I think the time has come to move beyond the terrarium if we really mean business with this agile dream. Otherwise, we're going to sort of have to kill that dream, right? That's the other option. If we want to reach this agile dream, I think we need to move beyond the terrarium. We need to turn these terrariums, these protective systems for the silkworm developers, into proper organizations in their own right, and then think of the larger organization as sort of like a loosely coupled alliance of smaller organizations. What I mean is that we need to give actual meaningful autonomy and independence to the teams, right? Not just stuff like, oh, we're going to choose our own technology. I mean autonomy as in actually working as an organization. This includes changing the mission or dissolving the team itself if the team sort of find out this is no longer useful. And to do that, you need to move the money inside, give the team a budget. Obviously, you need to put non-techies inside. Some people are having some progress on this, actually realizing that cross-functional means something more than having both a developer and a tester. You want someone that actually knows something about the domain as well. And you need to put the important decisions inside, not just the trivial ones. Not just, so are we going to use Java for this? Or could we perhaps try Haskell? That's sort of an unimportant decision from the business perspective. Put ownership inside, you give it to the team. You need direct communication with users and customers. And it's up to the team to do this now. It's not something that the team requests. It's something that the team does, right? It's their users, it's their customers. They just reach out. And without this direct communication, any idea of feedback is just bluffing. We're just fooling ourselves, right? We need this direct communication. At the team level, seeking independence, minimizing dependencies on others if we can, being explicit about what the dependencies we have if we cannot avoid the dependency. Obviously, protect internals. Anytime someone sort of comes in and grabs your data or have some sort of leeway into your priorities, that's going to lock you down, so you need to avoid that. Because we have all this changing hitting our software cyborgs, we need to actively retain and rebuild knowledge, because it's a fact that people will not stay with the project indefinitely. In fact, code lives longer than people in most projects or on most products. So we need to actively retain and rebuild knowledge. Best way I know to do that is to work in groups. Some people call this ensemble programming or mob programming or full team programming. I think we need to work in groups because that's the way to sort of spread knowledge. It's a good thing if we can seek stability, so we don't have too much of this churn of people, because the sort of knowledge loss is real. I think also that rewriting parts of the system is a useful way to do onboarding of new team members, because it sort of makes it safer to actually do some changes. At the architecture level, well, I'm just going to side with the teams. We had this sort of conflict of interest before, right? So it needs to be fit for purpose. You need to optimize for being understandable from within. And anything you do should be observability driven. And I think that your software doesn't really have any quality attributes that have not been validated in production and are not continuously validated in production so that you know that you have them. One thing is that you have an idea that you want to have these attributes, but you need to validate that they're actually there. We need to focus on simplicity, but for real, not in the sense that keep it simple, stupid, and you ain't going to need it, but then we proceed to build everything on Kubernetes and sort of stacks of YAML, which is sort of like I guess, like sentient accidental complexity, right? So we should minimize the moving parts if we can. Go brutalist in our architecture, so don't sort of abstract over it. Let's see what's there, right? We don't have to abstract a lot over HTTP. It is quite understandable. We should embrace constraints, not be afraid of constraints, but be very explicit about what we want to accomplish when we embrace constraints. We should try to preserve optionality, so make choices that don't lock you in for later decisions. Don't make assumptions that you don't have to. Planning for deletion is interesting. We put a lot of stuff into production, often with no idea of how we're going to get it out again. We know that we will at some point. And we should be very wary of generalizations. Don't generalize if you can avoid it, because any generalization is always a bet against the future, and the future can surprise you. I think it would be useful if we tried to reduce this change surface that I talked about, and that might initially cost a little bit more, because it might be that you cannot reuse some things that would have solved your problem, but maybe you can write just a little bit code yourself that solves your problem and sort of have, as an effect, a reduced change surface. And this might help shrink this iceberg that I was talking about. OK, that was a lot in a short time. I'll try to summarize. So first of all, I don't think it's a balance between agility and architecture. The idea is that we should do what's most valuable, and when something else turns more valuable, we should do some more of that. Architecture belongs inside the teams, not on the outside. We should try to smash the terrarium, and we need to build sustainable cyborgs. And that was all I had. I think it's actually 2 minutes for questions. Thank you.
Well, we don't have any Slido questions, of course, because we told people not to.
Oh, OK. Yeah.
If there's any spontaneous question, I would gladly pass it along. So, any takers? Eduardo.
Brilliant talk, Einar.
Thank you.
Can you share just a bit of some of your experiences on trying to, maybe, for example, where you are today, doing some of this, like firsthand, maybe some experiences bringing this message in the organization?
Yes, that's an excellent question, because it calls my bluff again, right? Which is always a good thing to do. NAV is a huge organization, so things will always be local there as well. And they always have their own sort of pressing concerns. So one thing is sort of just talking about this and sort of laying out that there is an alternative. Basically, so in my role, I'm what's known as a social-technical advisor, I guess. So I'm an advisor. I don't sort of enforce anything. So what I can do is to talk about, go to teams that have certain problems. Often those problems have something to do with their environment. And it's not immediately easy to sort of smash the terrarium, but at least starting with this acknowledging that there is a problem, that we have this insulation, and what can we do about it. And then the other part of that is to sort of empower teams, or sort of make teams aware that they can actually reach out to these people. Sometimes it feels more impossible than it really is. So I don't think I have more than that just yet, but that's, yeah.
Then I'll give you one more question from the audience.
OK.
Which kind of fits to what you just said, maybe. At least I think it does. The question would be, so would you agree that the architect in today's world and the future world is more of a facilitator in general? So is that a more skill to strive for, or?
Yes. So I think a lot of people are talking about sort of like, in terms of team topologies, right? They're just talking about sort of an enabling team of architects or something like that. And I think that might work. I worry a little bit about sort of a tendency for any skill that's scarce and expensive in our industry, that we turn it into an enabling team. So we have a little bit of the same with us, really, as a social technical advisor. We have the same problem with agile coaches. We have the same thing with anything, anywhere where there's sort of knowledge or experience is scarce and expensive. We sort of externalize it with the hope that they will be able to sort of plant seeds inside the teams. So it might work, but I'm a little bit worried, again, that you will still have these expert teams and not enough inside the teams themselves. But I don't have a good solution to basically the problem of scaling expertise in this way, because that's sort of the real problem, I guess. Does that make sense?
It does. To me, it does. So, like you said before, there's going to be lots of opportunities to discuss things, and I definitely want to discuss a couple of things, like rewriting as an onboarding. I'd really like to talk about that one. But let's do that later. So once again, thank you very much,
Perfect.
Einar.
Thanks for having me.